All right, hey guys. So we're going to get into our gas laws here. We've already talked about pressure and partial pressure, and now we're going to really start talking about the relationships between pressure, volume, and temperature. And the first one we're going to talk about today is what's called Boyle's Law. And Boyle's Law tells us about the relationship between the pressure and the volume of a gas. So let's go ahead and talk about Boyle's Law. And our target is to be able to use Boyle's Law, Charles' Law, Gay-Lussac's Law, and the combined gas law to solve problems involving temperature, pressure, and volume. So today, Boyle's Law. Let's get to it. Okay, so Boyle's Law, named after Robert Boyle, who was an English scientist. Boyle's Law describes the relationship between the pressure and the volume of a gas in a sealed container. Okay, that's an important point, in a sealed container, because the gas can't escape. So, if you have a gas and you increase the pressure, what's going to happen to the volume? Or if you increase the volume, what's going to happen to the pressure, and so forth, right? Good way to think about this, I have here a syringe, right? And this is the kind of thing that they give you a shot with, but there's no needle on it, so it's not going to poke me or anything, right? And in my syringe, there's a scale on there, so I can see, how many milliliters of air is in my syringe. So let's say I put it right here at about 20, okay? So there's 20 milliliters of air in my syringe. If I put my finger over the end, that air can't escape. And then if I push on it, you can see the air gets smaller. I can probably get it down to about 5 milliliters, okay? So the volume has gone from 20 milliliters to 5 milliliters. What do you think happened to the pressure of the air inside of that syringe? Do you think the pressure got higher or lower? That pressure definitely got higher, right? I can feel it trying to push the syringe back out. The pressure in there is pretty high. So when the volume of a gas goes down, what happens to its pressure? The pressure goes up. Similarly, the opposite way, if I set my volume pretty low there and I try to pull this out, well, that's not sealed up very good, but if I pulled it out, you would see that the pressure would get lower. So when the volume gets bigger, the pressure gets lower, right? So we can use the syringe there to kind of tell us a little bit about what's going to happen when you change the volume or the pressure of a gas. Makes a lot of sense why this happens if you think about why pressure happens in the first place, right? Pressure happens on the sides of a container of a gas because the atoms and molecules of that gas are bouncing around. They're bouncing around, hitting the sides of the container. And the pressure results from them striking the sides of the container, right? And if you make the volume smaller, then they have less room to bounce around. They're going to strike the sides of the container more often. The pressure is going to be higher. If you make the volume bigger, they're going to have more room to bounce around, and they're going to strike the sides of the container less often, which means the pressure will be lower. So it makes a lot of sense if you think about why that kind of thing happens. Okay, Boyle's Law. Usually we write Boyle's Law like this. It says that the pressure, it says P1V1 equals P2V2. What that means is if you take the pressure and the volume of a gas before they change and multiply them together, that'll be equal to the pressure times the volume of that gas after it changes. So you can see P for pressure, V for volume. The ones mean this is the number before the gas changed, and the twos mean this is the number after the gas changed. It actually doesn't really matter which one is before and which one is after. The math works out the same either way, but it's a good way to think about it. The little ones mean before the gas changed, and the little twos mean after the gas changed. So this here, Boyle's Law. Let's go take a look at an example of how to use it to solve a problem. Let's have a look at this example here. It says, find the final volume of a gas if 4 liters of it were changed from 2.5 atmospheres to 5 atmospheres. Okay, I'm going to show you kind of the best way to set up and solve this problem. We've got a few different numbers in the problem, and we need to organize them and understand what they are. So I'm going to read the problem, and I'm going to think about which numbers are pressures, which numbers are volumes and which numbers are before and which numbers are after. Okay, so I need to identify what is pressure 1, what is volume 1, what is pressure 2, and what is volume 2. And one of those, the question asked me to find. So what I'm going to do is I'm going to write out a list. I'm going to say, okay, this is pressure 1, this is volume 1, this is pressure 2, and this is volume 2. I'm going to look in the problem and see if I can find these numbers. Okay, so the first number I see there says 4 liters. Liters tells me this is a volume. Okay, so it says 4 liters were changed from 2.5 atmospheres to 5 atmospheres, which if you read the problem there, the 4 liters is before the change. So this is volume 1, 4 liters. Okay, and then the next numbers you see are both pressures. See, this is 2.5 atmospheres to 5 atmospheres. What that's telling me is that the pressure before was 2.5 and the pressure after was 5. So pressure 1 is 2.5 atmospheres and pressure 2 is 5 atmospheres. Now I'm going to tell you what the units that we use with Boyle's Law don't matter that much, so long as our 2 pressures have the same units and our 2 volumes have the same units. Okay, so they don't have to be any particular unit, they just have to be the same units, right? So for my pressure here is in atmospheres and my pressure here is in atmospheres. They need to be the same. So here my volume is in liters. When I get my answer here, because this is what they asked me to find, that will also be in liters. Okay, so let's put these numbers into this equation and then we'll solve it and we'll see what the answer is. So it says pressure 1 times volume 1. So here I have 2.5 times 4 equals pressure 2 times volume 2. So here I have 5 times, I don't know, right? And what I'm going to do for the I don't know is I'm just going to leave this variable, V2. So 5 times V2. Okay. Now at this point, you're either going to have 2 numbers on this side of the equation, or you're going to have 2 numbers on this side of the equation. Whichever side, multiply those 2 numbers. So here I have 2.5 times 4. I'm going to get my calculator, and that should come out to 10. And on the other side, you're going to have a number and a variable. Just bring those down. 5 times V2. And then I hope everybody can see how we're going to solve this at the end. All we have to do is we need to divide by that number that's with the variable. So now here, I'm going to divide both sides by 5. So I'm going to do 10 divided by 5, which is going to give me 2. And on this side, I've got left V2. Okay. And like we mentioned a minute before, we need a unit to put on that answer, right? And it's going to be the same as the other volume. The other volume was in liters, so it's 2 liters. And that is how we use Boyle's Law to solve a problem. Now, do you absolutely have to list out all of the 4 things before you start setting it up? You don't absolutely have to, but I highly suggest you do. It's going to help you stay organized, and it's going to help you identify what's what, so you don't put a number in the wrong place, so you don't get lost and confused, right? So I like to, every time I solve a problem like this, I list each variable, each thing that I know, and then I put the numbers into the equation. Okay, here's another example. It says a sample of oxygen gas has a volume of 150 milliliters when its pressure is 0.947 atmospheres. What will the volume of the gas be at a pressure of 0.987 atmospheres? Okay, so we need to identify pressure 1, volume 1, pressure 2, and volume 2. Okay, let's see, the first number it gives me there is a volume, 150 milliliters, and that is before the gas changed, 150 milliliters. Notice in the last one we had liters, and this one we had milliliters. It's okay, we can use either unit. Okay, and it said the volume was 150 milliliters when the pressure was 0.947 atmospheres. So that is the pressure that goes with it, 0.947 atmospheres. Okay. And then it says, what will the volume of the gas be? So we don't know this. When the pressure is 0.987. 0.987 atmospheres. Okay. Now let's make sure our units are okay. Our two pressures need to have the same units, and I can see that they are both in atmospheres. So that's good. Okay. My volume is in milliliters, so when I get my answer, it will also be in milliliters. So let me set this up and solve it. So pressure 1 times volume 1, 0.947 times 150 equals pressure 2 times volume 2. So that's 0.987 times volume 2. Okay. Now I see two numbers on the side. I'm going to multiply them. So 0.947 times 150 gives me about 142. And on the other side here, I've got I'm going to bring down the other side, 987 times V2. Okay. Now we can see to solve this, we just need to divide by this number. So I'm going to take 142 divided by 0.987. So let's divide by 0.987. And I get volume 2 is equal to about 144. And we need a unit to put on there like we mentioned a minute ago. Our unit for the volume 2 is going to have the same units as this volume 1. So it's going to be in milliliters. Pretty easy there, not too hard. So there we go. We talked about the relationship between the pressure and the temperature of a gas. We learned Boyle's Law, and we did a couple of examples there. So hopefully that helps us to be able to use Boyle's Law, Charles' Law, Gay-Lussac's Law, and the combined gas law to solve problems involving temperature, pressure, and volume. Bet you can't guess what the next law we're going to learn is called. Until then, take it easy.